Hello there and welcome to A2 Maths on Specimen Paper 1, and here we're looking at question 10 and functions question. So the function f is defined by f takes x to 3x minus 5 over x plus 1, find the inverse function. So what we do with inverse functions questions is we set up the equation that helps work out the output, x being our input value, and we set this equal to an output value, and we set that output value equal to y. Now what we want to do is we want to create a formula that takes output values back to input values. So what we need to do is rearrange this to make x the subject. So first thing we're going to do then is we're going to multiply by x plus 1 onto the other side. We're then going to expand the brackets. And now what we want to do, to make x the subject, we want to get x on the same side. So I'm going to take away x, y onto the right, and then anything that doesn't have an x in it needs to go on the right hand side, or whichever side you want it to, but in this case I'm doing left hand side to right hand side. Okay, what we need to do now is how can we convert these two x values into just a single x value? Well, what we can do is we can factorize x bracket 3 minus y equals y plus 5, and then divide by 3 minus y, so it's going to be y plus 5 over 3 minus y. So therefore the final answer, f inverse in terms of x, is going to be this equation here. This equation takes the output value y, you calculate this value and it takes you back to the input value x, so therefore it's clearly an inverse function. But what we do, just to change things up a little bit, just for standard notation reasons, is that we change all the y's into x's. I almost forgot to do the last one there, but there we are. We change all the y's into x's for our final answer. Moving on to part B now, it's a composite functions question. So we've got f of x equals x plus a over x minus 1. So let's start by writing out what this composite function is going to be. It's going to be f of the f function, which is 3x minus 5 over x plus 1. And now we need to do this function again. So what we're going to do is we're going to take the output from this function and put it in as x in both places in the f of x formula. So it's going to look like 3 brackets 3x minus 5 over x plus 1 minus 5 over 3x plus 5 over x plus 1. Whoops, it's supposed to be a minus 5 there. Plus 1. There we are, great. So what we've done is we've put the f function into both of the x positions in the f function again, because it's two f functions. Right, what we need to do then is we now need to simplify this, and the easiest way we can do this, we could simplify the top, simplify the bottom, and then see where we go from there. An easier way of doing it would be to times top and bottom by x plus 1. Reason being is that that's the denominator on both the fractions on the numerator and the denominator, and it will cancel them out when we multiply all the parts out. So let's start multiplying the top and the bottom. Remember also that whenever you take a fraction and you multiply the top and bottom by the same value, you end up with an equivalent fraction. So we're keeping things equal here. Expanding this out, when we times 3 brackets 3x minus 5 over x plus 1 by x plus 1, the x plus 1s will cancel out on the top and bottom, so we're left with 3x minus 5. But we do need to times the x plus 1 by this minus 5 as well, so it's going to be minus 5x plus 1. And then it's all going to be over. Expanding the denominator out now, we just end up with the value on the numerator inside this denominator, and then it's going to be plus 1 times this x plus 1, so that's going to be x plus 1. Okay, so if that bit has taken a little while for you to get your head around, do pause the video and just try it out, try multiplying everything out and see that it does equal this. But I'm going to carry on now, so we're going to now expand the brackets and simplify numerator and denominator. 3 times 3 is 9, take away 5, that's 4x. Minus 15, take away 5, that's minus 20. Over, it's going to be 3x plus x, that's 4x. And then it's going to be minus 5 plus 1, that's minus 4. So cancelling out 4's from top and bottom, we get x minus 5 over x minus 1. So there we are, that's the answer. So a here is equal to minus 5. Great, that's the answer for part B then. Part C, a new function g. G takes x to x squared minus 3x between 0 and 5. Find the value of fg of 2. So, fg of 2, so we do the g function first. Remember, when you do composite functions, you work with the function that's closest to the value, to the numerical value first. So g, we're going to do 2 into g first. So that's going to be 4 minus 6, that's minus 2. And then minus 2 into the f function, that's going to be minus 6 minus 5 over minus 2 plus 1. That's going to be minus 11 over minus 1, so that's going to be 11. Great, so that's the answer to part C. Find the range of the g function. Okay, so what we need to consider then is that g is a value in between 0 to 5. It would be helpful to be able to sketch the curve of x squared minus 3x. So x squared minus 3x, we can write that this is equivalent to, let's complete the square on this, I think, x minus 3 over 2 squared, and then it's going to be minus 9 over 4. So the equation is going to have a y-intercept at 9 over 4, and it's going to have a minimum point at, sorry, no, that's wrong. It's going to have a y-intercept at 0, because when we look at this part of the equation, the y-intercept is 0. It's going to have a minimum point at plus 3 over 2, because the transformation works to the right, down to 9 over 4. So it's going to have a minimum point of 3 over 2, 9 over 4. 3 over 2 is less than 5, so it's going to come down here and back up again. Let's plug 5 into the equation to find its maximum point. 5 squared is 25, minus 3 times 5, that's 15. 25 minus 15 is 10, so it's going to go all the way up to 10. So, therefore, the range for this function is going to be in between and equal to minus 9 over 4 and up to 10. So there we are, that's the range for this function here. Really important that we consider that it's a quadratic, and it's the range of possible outputs that go from minus 9 over 4 and up to 10. If we're answering now part E, explain why the function g does not have an inverse. It's because it's a one-to-many function. No, it's a many-to-one function. Many-to-one function. It must be a one-to-one function to have an inverse. It must be a one-to-one function to have an inverse. Okay, and we can see that it's a many-to-one function because many x values takes it to the same single one output value, so therefore it's a many-to-one function. So there we are, that's the answer to this 13-mark question there. Then that's question 10. So yeah, 13 marks for that, not too bad really. I think students generally struggle on the range type questions. Just draw the graph. Any range question, just draw the graph and you'll see that it's the total value of y outputs that is the range. So there we are, question 10, 13 marks. Let's move on to question 11.